We're working out how far we have to go.
Yeah, where we have to put it,
With
make a
the
telescope
second
to make
lens.
put two
Magnifying
lenses.
glass, whatever else.
Yeah, I mean, you basically could do a microscope or a telescope if you have the right lenses and put them at the right distances.
How do we use that, though?
What?
This equation?
First of all, you got the equation wrong. The F and the I should be reversed.
Focal length is 20.
It isn't really 20 though from our experience, is it? Because the phone's 20 centimeters away, the mirror's there, and then the image at its clearest point was 22 centimeters away from the lens. It wasn't really 20.
The image will be somewhere different than the focus, though.
Oh, yeah, true.
Yeah,
Sorry.
the image and the object distance both have to be greater than the focal distance, so that both those fractions will be less than 1 over F, right?
So what was the image distance?
Of course, you need to understand this in terms of the light path and the triangles and all that stuff. It's just geometry.
What's O stand for?
Object distance.
Object.
How far the thing was from the lens.
Oh, that was 20 centimeters.
So was it 20 centimeters from the lens to the object? Or to the image?
It's 22 from the lens to the image, 20 from the phone to the lens. Because we had the phone at 0, we had the lens at 20, and we had the image at 42.
This would be negative, though, wouldn't it?
Image at 42 from what?
From the phone. We have it on a meter
Okay,
stick.
but the object distance, but both the image and object distances are measured from the lens.
Okay,
So if you add those two up, you get something pretty close to 1/10. And you don't have a negative.
You get...
No,
240.
that's not how you add fractions.
Oh man, yeah. Multiples.
You know, I
Let's
got
just
that
leave
on
it.
tape. I can probably blackmail
Did
you
you
for
get
the rest
that
of your
one?
life.
Alright, let's delete that.
Let's just make it 1/10. And
I don't think my face was in.
Plausible deniability. That'd be what, 440 is a common denominator?
Yeah, but what's 1/20th plus 1/20th?
120 plus
2/20.
1/10.
Yeah,
And it's close enough.
so that's pretty close to 1/20th plus 1/20th, right? So you don't have to go to all that trouble because you know that your measurements will tend to be off by maybe up to a centimeter, right?
Yeah.
Also, the lens isn't all that thin. It's got some thickness.
So the focal
So that's a-
distance should be 10 centimeters?
Well, that's what I gave you, is a 10 centimeter focal length. I think I told you that. Matter of fact, that was marked on the package.
Let's find let's test it.
And you can test it. How can you test whether it's a 10 centimeter focal length? 2 ways.
Shine a light through and see where the focus is.
More specifically,
See how far the focus is from the lens.
how do you know where the focus is?
Whenever you get the smallest, brightest dot on the piece of paper.
No, that's not the focal point. That's the
image.
object distance, or the image distance. How would you get your object, I mean your image, to be at the focal distance? And you should be able to explain this by ray tracing, not by using a formula, but go ahead and use the formula for now. You don't deserve to use it unless you can derive it. You probably will anyhow.
I guess make the object distance 0.
The reciprocal of 0 is problematic.
Okay, make it very large then.
Yeah. An infinite object distance will give you an image at the focal point, because parallel rays come from an infinitely distant object, and that's where the parallel rays go, to the focal point. Basic principle.
Okay. So the object distance is the distance between the source and the lens, right?
Yeah. Yeah, like that board over there that I haven't erased. That thing that you see every time you walk in, don't pay any attention to because you're so excited about what you're going to learn. Okay? So you got that, The other way is to put your object at the focal distance, which does what to the image distance?
Makes it infinite.
Yeah. If the image distance is infinite, well, it's like this. Here is rays from an infinitely distant object, right? And they focus at the focal point, okay? And that's where the image of the infinitely distant object will be, at the focal point, okay?
So that's practically we could just use the sun.
The what?
We could just use sunlight at that point.
Yeah, if you want to burn ants, that's where you put the ants. Of course, the ants won't hold still, you got to move the lens around, but you can do that. Okay, so the other thing though is if your object is here, then here are the rays from the object and they come out parallel and that's your spotlight, which we did night before last. Okay?
So if you put the source at the focal distance, you'll have the spotlight.
Yeah. So that's two ways to get the focal distance. You saw what I did over there where I got the spotlight, I figured the distance would give me the spotlight so I could see what the focal distance was, right? Okay? So you got to know all that, again, and you got to know how to do the ray tracing. So first of all, prove that. It's fairly straightforward, just 8th grade geometry. Just proportionalities, no algebra involved, okay? And so forth. Okay. Well, this other thing here, I might as well get a tape of it.